Mathematics, Analysis and Approaches, Paper 2, Timezone 1, HL, November 2025. This is a 18-mark question, and this is question number 11. He's asking us to use integration by parts to integrate cos inverse of x. And he also says that there is a probability distribution function, which is so and so. I need to show that this is going to be the answer. We will look at how to achieve this, and then we will also look at how to find the value for k. Find the expected value of x and then the variance of x, and given that the mean is the expected value and the variance is variance of x, find out the probability of x being between one standard deviation away from the mean. Now that's what he's asking for. Let's quickly look at the first part of the question. Here I'm going to be applying integration by parts. So I have only one function, so I'm going to write this as integral of 1 into cos inverse of x dx. So my u, as per ILATE, is going to be cos inverse of x, and my v, dv, is going to be equal to 1. So du, which is the differential of cos inverse of x, is minus 1 over root of 1 minus x squared, and then the integral of v, which is x. Now I hope you all know what is ILATE. Depending on that, I'm going to be choosing my u. I is a inverse, logarithmic, algebraic, trigonometric, and exponential. So in this I have algebraic and then inverse trigonometric. So because inverse trigonometric takes a preference, I took u as cos inverse of x. Let's move on. Now, what is the integral of u dv, which is basically integration by parts, is going to be equal to u into v minus integral of v du. So I'm going to go back here and write u into v, which is x cos inverse of x, minus integral of v du, and that's going to be x into minus 1 over root of 1 minus x squared dx. I'm going to rewrite this as x cos inverse of x plus integral of x divided by root of 1 minus x squared dx. So let's take this integral separately and then try to integrate it. I'm going to take 1 minus x squared, which is under the root, as, let's say, another variable t, and then I differentiate this. This is going to become minus 2x dx as equal to dt, and that would mean that x dx is minus dt by 2. So this integral will now change to minus 1 over 2 divided by root t dt. So I can take a negative 1 over 2 common out, and then integral t to the power of minus half dt. And the integral of t to the power of minus half is simply t to the power of half divided by half. These two will get cancelled. So what I remain with is minus root t. Plus a constant, of course, but I'm not going to write that here. I'm going to simply write this as So for the second part of the question, I'll have to integrate the probability density function from 0 to k, and then I'll be equating that to a 1. What we know is that in a discrete random variable, where I will have a probability mass function, the sum of all the probabilities is going to be a 1. Likewise, in this is a probability density function, and this is a continuous random variable, and therefore when I'm integrating the PDF or the probability density function from 0 to k, I'll be equating that to a 1 because the area is going to be a 1 under the curve. So I go back to the second part and I start my integration process. This, you can see, has two functions, x and cos inverse of x squared. I know that when I substitute x squared as equal to u or any other variable, x would come out as one of the differentiated function. And therefore, first I'm going to go with substitution and then apply integration by parts if necessary. So let's say x squared is equal to t. Then when I differentiate, I get 2x dx as equal to dt. That means x dx is going to be dt by 2. Take the 3 common out. Now, because I'm changing the variable, my limits also needs to change. When x is equal to 0, t is also going to be 0. And when x is equal to k, t is going to be equal to k square. So the limits is going to be from 0 to k square, and x dx is going to be dt by 2. So I'm going to take a 2 common out here, and what I'll have is cos inverse of t dt. And I already know the integration of cos inverse of t. I'm going to simply write that here. So that's 3 over 2, and the integration of cos inverse of t is that. We found the integration of cos inverse of x is the same thing for cos inverse of t. So that's, and the limit is from 0 to k square. Let's go ahead and substitute the value for k square in this. So that's going to give me 3 over 2, open parenthesis, k square cos inverse of k square minus root of 1 minus k to the power of 4. And then I'm going to be substituting a 0. So the first one is simply going to be 0 into cos inverse of 0, which is 0, minus root of 1 minus 0, which is simply a 1. Plus 1. And this is going to be the integral. And as I said that this entire integral is going to be equal to 1. So I'm going to start equating that to a 1. And when I transpose it, equal to 0. And that proves the B first part. Hence, find the value for k, giving your answer in correct to significant figures. All I can do now is to take this function and put it onto the calculator and get the value for k. And from there, I get the value for k as equal to 0.713250. I'm writing that because he's asking for the answer in 6 significant figures. So that's your answer there. Let's now calculate the expected value of x. The expected value of x is simply integral of x p of x. This is how you calculate the expected value of x. So let's go ahead and do that. So I'm going to substitute that here. So this is going to become integral 3x square into cos inverse of x square dx. And this will be integrated from 0 to k. And I know the value for k. The value for k is 0.713250. For variance, we have 2 different approaches. I'm going to try and do any one of them. Ideally, the variance is calculated as how much is every value deviating from the mean. And then I'm going to square that up and then multiply it with the corresponding frequencies. That's what you do in statistics. In this case, we're going to be multiplying with the corresponding probabilities, and because we are dealing with a continuous random variable, we're going to write f of x, which is the probability density function, and this will be integrated from 0 to k, and k in this case is 0.713250. Now, this is one way of doing it. The other way of doing it is to simply calculate the expected value of x square minus the expected value of x, the whole square. We already know this value, expected value of x, so all I need to do is to calculate the expected value of x square. I think that would be a bit more easier, or we can go ahead and do this also and then enter that into the calculator directly. Both are fine. I'm going to take this approach, which is to calculate the expected value of x square. I know that the expected value of x is going to be integral x p of x dx. So expected value of x square is integral x square p of x. In this case, p of x is simply going to be equal to 3x cos inverse of x square dx. And that's going to be integrated from 0 to 0.71350. The last part is to calculate the probability of the random variable being between one standard deviation away. What I do know is that the variance which I calculated, 0.029, this is the variance. From here, we're going to calculate the standard deviation, which is root of this vector number. So let me quickly do that. Let's now calculate one standard deviation away. And that's what I end up getting as an answer. If you look at the mark scheme, let me actually show you the mark scheme here. The value that you get is 0.620. The reason being that he is taking a lot of decimal values, and that is why he has that answer. You can see we approximated it to 0.71. He hasn't, and therefore the answer would differ a bit. And that's your solution for question number 11. That's it for this video. Thank you.